Hello everyone, welcome to new class. Today's class is applications of determinants and matrices. So let us discuss about the applications of determinants and matrices for solving the system of linear equations with two or three variables and for checking the consistency of the system of linear equations. So before that, what is consistent system and inconsistent system? A system of equations is said to be consistent if its solution exists, and a system of equations is said to be inconsistent if its solution does not exist. So that is about the consistent system and inconsistent system. So if there is a solution, it is consistent system, and if there is no solution, then it is inconsistent system. Then let us study about the solution of system of linear equation using inverse of a matrix. So consider the system of equations a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z is equal to d3. And let A is equal to matrix A1 B1 C1, A2 B2 C2, A3 B3 C3. That is, A is the matrix with the coefficients of x, y and z. Then let capital X is equal to the unknown variables x, y, z, and which is a column matrix. And let B is equal to the constant in this equation, that is column matrix of D1, D2 and D3. Then this equation can be written using these matrices in the form, that is Ax is equal to B. That is, this can be written as A into X, that is A is A1 B1 C1, A2 B2 C2, then A3 B3 C3. So this is A, then into X. So X is the column matrix of X, Y and Z, and that is equal to B. B is the column matrix of the constant D1, D2 and D3. So this linear equation can be written in the form of matrix like this, that is Ax is equal to B. Now we can go for the solution of this matrix, that is we can find the value of x using the inverse of matrix. So let us go for that solution. So first case is, if A is non-singular matrix, then its inverse exists. So consider A as a non-singular matrix. So if A is a non-singular matrix, then its inverse exists. So we can write this as, that is Ax is equal to B. Then pre-multiplying by A inverse. So pre-multiply by A inverse. Here we will get A inverse into A into X is equal to A inverse into B. And this A inverse into A is the I matrix. So I into X is equal to A inverse into B. And what is this I into X? So I into X means it is X. So X is equal to A inverse into B. So this is the solution of this linear equation. So X is equal to A inverse into B. So Ax equal to B is written in matrix form for the system of linear equations, and the solution of this equation is x is equal to A inverse into B. So that is the case of if A is non-singular matrix, and this method of solving equation is known as matrix method. The next case is if A is a singular matrix, that is determinant of A is equal to 0. So in non-singular matrix, we have determinant of A not equal to 0. Then only we can find the value of A inverse. Then the second case is if A is a singular matrix, that is when the determinant of A is equal to 0. Then in this case, we have to calculate adjoint of A into B. And if adjoint of A into B is not equal to 0, then there is no solution. That is, solution does not exist and the system of equations is called inconsistent. Then the second case is if adjoint of A into B is equal to 0, then system may be either consistent or inconsistent according as the system have either infinitely many solutions or no solution. So these are about the solutions of system of linear equations. Let us do a problem. Solve the system of equations 2x plus 5y equal to 1, 3x plus 2y equal to 7. So this can be written in the form of matrix like Ax equal to B. That is, here A is the coefficients of x and y. That is 2, 5, then 3 and 2. And x is equal to x and y are the unknowns. Then b is equal to 1 and 7. That is the constants. So to find the unknown values x and y, we have to check whether this a is singular or not. So for that we have to find the value of determinant of a. That is 2 into 2 is 4 minus 5 into 3 15 and that is equal to minus 11. So it is a non-singular matrix. So inverse of the matrix exists. So we can find the unknown variables using this relation, that is x is equal to A inverse into B. So for that we have to find A inverse. So before that we have to find the value of adjoint of A. So what is adjoint of A? So this is a 2 by 2 matrix. So interchange the diagonal element. So here it is 2. Then change the sign of non-diagonal element. So this is the adjoint of A. Then what is A inverse? So A inverse is equal to 1 by determinant of A into adjoint of A. And that is equal to here 1 by determinant of A means it is minus 1 by 11 into 2 minus 5 minus 3 and 2. Now we can find the value of this x. That is x is equal to A inverse into B. So x is equal to A inverse is this one. So minus 1 by 11 into 2 minus 5 minus 3 and 2. Then into B is 1 and 7. And that is equal to, so here 2 into 1 is 2. Then minus 5 into 7, that is minus 35, that is minus 33. And here minus 1 by 11 is there. Then minus 3 into 1, that is minus 3. Then plus 2 into 7, that is 14. So here we will get 11. So, and this is equal to minus 1 by 11 into minus 33, that is plus 3. Then minus 1 by 11 into 11, that is 1, minus 1. So this is the value of x. So what it means? So x is equal to 3 and minus 1, that is, this is x and y. So x is equal to 3 and y is equal to minus 1. So this is the solution for this system of equations. Let us do next problem. Solve the system of equations by matrix method. 3x minus 2y plus 3z equal to 8. 2x plus y minus z equal to 1. 4x minus 3y plus 2z equal to 4. So this can be written in the form Ax is equal to B, where A is equal to matrix 3 minus 2, 3, 2, 1 minus 1, 4 minus 3, 2 and x is equal to x, y, z are the unknown values. Then B is equal to 8, 1, 4. Now here we have to find the value of determinant of A. to check whether this A is non-singular or not. So determinant of A is equal to 3 into 1 into 2, 2 minus 3, that is minus 1. Then minus of minus plus 2 into 2, 4 plus 4, that is 8. Then plus 3 into 2 into minus 3, that is minus 6 minus 4, that is minus 10. And that is equal to minus 3 plus 16 minus 30. And that is equal to, so 30 minus 33 plus 16. And that is minus 17. So determinant of A is not equal to 0, that is A is non-singular matrix, hence inverse of the matrix exists. So we can find the inverse of the matrix. So for that we have to find the adjoint of A. So for that we have to find the values of cofactor elements. That is A11 is equal to 1 into M11. So M11 is 2 minus 3, that is minus 1. Then A12 is minus 1 into M12. So M12 is 2 plus 4, that is 8 minus 8. Then A13 is 1 into M13, that is minus 6 minus 4, that is minus 10. Then A21 is minus 1 into M21. So M21 is deleting this column and row. So minus 4 minus 9. So minus 4 plus 9 is 5. That is minus 5. Then A22 is plus 1 into 6 minus 12. That is minus 6. Then A23 is equal to minus 1 into minus 9 plus 8. That is minus 1. Then A31 is 1 into 2 minus 3, that is minus 1. Then A32 is minus 1 into minus 3 minus 6, that is minus 9, that is plus 9. Then A33 is equal to 1 into M33, 3 plus 4, that is 7. So these are the cofactor elements. Now cofactor matrix. Cofactor matrix is equal to minus 1, minus 8, minus 10, then minus 5, minus 6, 1, minus 1, 9 and 7. So this is the cofactor matrix. Now adjoint of A is equal to transpose of this matrix, that is change the rows into columns. So minus 1, minus 8, minus 10, minus 5, minus 6, 1, then minus 1, 9 and 7. So this is adjoint of A. Now we can find the value of A inverse. That is A inverse is equal to adjoint A divided by determinant of A. And from that we can find the value of the solution of the equation. That is solution of equation is x is equal to A inverse into B. So x is equal to A inverse into B. So A inverse is 1 by determinant of A into adjoint of A, then into B. Now we can find the values, that is minus 1 by 17 into, first one is minus 1 into 8, that is minus 8, then minus 5, then minus 4. So 8, 5 and 4, that is minus 17. Then minus 8 into 8, that is minus 64, then minus 6, then plus 36, that is minus 70 plus 36, that is minus 34. Then next is minus 80, then plus 1, then plus 28, that is minus 80 plus 29, that is minus 51. That is equal to, so here we can divide or multiply this minus 1 by 17 with each of these. So here we will get plus 1. Then here minus 34 divided by 17, that is 2. Then minus 51 divided by 17, that is 3. So x is equal to 1, 2, 3. So x is equal to 1, 2, 3 means the solution is x is equal to 1, then y is equal to 2 and z is equal to 3. So this is the solution of the given equation. So that is about the applications of determinants, that is solving the system of equations by matrix method. So in the next class, let us discuss more problems related to this system of equations. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.